This even in the today in the review. So this is e to 4x over 4 minus x to the third over 3 plus, please must write absolute value. Okay, that's the reason why I had this little discussion, just to make sure that you understand it has to have absolute value. And you must write plus a constant c, because this is the most general antiderivative, the indefinite integral of f of x dx, and it has for each term whatever, but it has to have plus a constant c because this represents the most general antiderivative. It's the family of functions whose derivative is this function. Okay, perfect. Now, let's continue back to the book. Where is my book? Who knows where my book is? Here, here, here. No, here. Yeah, the book disappears if I... Where is it? It should be. No, okay, fine. It's here. Okay, so I wanted to move on to any word problem just to illustrate what we are trying to do here. And we've done this before last time. It's not... Okay, so I don't know, you choose. So total cost from marginal cost. Clio's Custom Fabrics has found that its marginal cost, this one, in dollars per yard, of course, it's a rate of change. It has to have two measurement units, dollars per yard, is this for anything less than 350 yards of fabric produced. Find the total cost of producing 200 yards of this fabric. So let's look at 31. We are given c prime of x as negative 0.007x plus 12. And they're telling us that this function is valid as long as we have less than 350 yards of fabric. They're asking us to find the total cost from producing 200 yards. Okay. We do not have the total cost. We have the marginal cost. How do I determine the total cost? Total cost function is c of x. Marginal is c prime. How do I determine, if I have the c prime, how do I determine the function c? What is the process called? We either say I find the, or I apply something. What is this for this? That fancy word. It is the
derivative.
Yes, derivative of c prime of x. And it is obtained by integration. Obtained by integration. So, c of x. Which function prime is negative 0.007 blah 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 x? Basically, I should ask which function prime is x, because the constant stays.
X squared over 2.
Excellent. Plus, which function prime is 12? What do we do? Yes. And we can never forget plus. I'm not going to use c, I'm going to use d this time, because c and d are not different things. So if I use c, you may get confused with this. A constant d. Well, in this case, because we're talking about cost, if x is 0, the cost is 0. So this can be omitted as being 0. Now I have the function. I can plug in I meant to write 200 here. I can plug in 200. Good. So negative 0.007 times 200 squared over 2 plus 12 times 200. Quickly, I'll not share because it's too easy. Negative 0.007 multiplied by 200 squared, and then divide by 2 and plus 12 times 200. I got 2260. Since it's cost, it's not marginal cost. The marginal cost will be in dollars per unit because it has two measurement units, is the rate of change. But this one is in dollars because that's the cost. Any questions on 31? Any questions on 31? Any questions? Okay, in that case, I'd like to continue. We are moving on. And that's at my page 4. We're moving on to 4.3. In 4.3, we are going to learn the fundamental theorem of calculus. It has two parts. Your book presents only one part, okay? So I'm not going to talk about the second one. It only presents one. What does the fundamental theorem of calculus teach us? It shows how to evaluate a definite this integral is the indefinite integral. Fundamental theorem of calculus shows how to evaluate a definite. And what is that? Integral. Okay. So a few minutes ago, we looked at the graph that was 1 over x squared. And they showed us 6 intervals, I think between 1 and 7. They showed us 6 intervals, 1, 2, 3, 4, 5. Okay, I have to squeeze one more. Okay. And they used, I believe, the leftmost point, because that's how we calculated. And we determined that this area is an overestimate, and I think it was 1.49, something like that. We know it's more than it is. True, exact area. It's more. But we determined it using the leftmost point. Well, how did we discuss this last time? Normally, when we determine the limit, as the number of subintervals goes to infinity, from that Riemann sum, right, function times dx, and that's the sum of them, sum, we said that this was exact. But as you've noticed, this is not easy to calculate. I do this in my 191 class with many functions, not all of them. We are restricted. We are very few, basically. But not in this class. There is no need to go through this. Here we go directly to another method. What method? The definite integral. What is that? So in order to determine the area, we'll find the limit. But this is a cumbersome method. We will find the exact area for certain functions, but it's a difficult method. Instead, we have this one. What is a definite integral versus an indefinite integral? So let's analyze and separate them and discuss them together. The indefinite integral from f of x dx is a function, the antiderivative, plus a constant c, which is a family of functions. Which I can easily check. If I differentiate this, I should get that. And I'm going to write that. F of x plus c prime has to give us f of x. This is the indefinite integral. Okay, how does the definite integral look like? Still the same symbol, still f of x, of course still dx, but it has limits of integration. Doesn't mean that I'm talking about limit. No, 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 no. It has limits of integration. In other words, for this, it would be the integral from 1 to 7 from 1 over x squared dx. So this is the definite integral. I'm going to make sure they are separated. The indefinite does not have limits of integration, and the answer is a function, a family of functions. The definite integral, definite, from this to this. This is general, indefinite, family of functions. But this one, no, this one is exact, between 1 and 7, from a to b, from f of x dx. The answer is a number, not a function, like this one. So the indefinite gives us a general case. All functions whose derivative is the given function here. This one says, find the exact area between 1 and 7 under the graph of 1 over x squared. So this is also the area, the exact. This is not an area. This is a general case, an indefinite integral family of functions. This one is exact, and it's the exact area, and it's a number, and it's called a definite. It has limits of integration, not limit, L-I-M, no, no, limits of integration. It starts here and it ends here. Now, can I determine this? Yes, I can. Exact? Yes. And this is what we learned from the fundamental theorem of calculus. I have to explain it, and then we'll determine this. So the fundamental theorem of calculus says the following. If you want to determine the definite integral from a to b from f of x dx, you will still have to find the antiderivative, guaranteed. You write a vertical bar, you copy the limits of integration from a to b, and then you plug in b, and you subtract when you plug in a. This is the procedure of finding or evaluating a definite integral. This is the fundamental theorem of calculus. What does it do? Again, it says if you need to determine the definite integral from a to b from f of x dx, find like before, no change, find like before the antiderivative, write a vertical bar with these limits of integration, plug in b always from the top, plug in the top one and subtract when you plug in the bottom one. Before I do this one, I want to do a simpler one. Let's say the integral from -3 to 4 from 4x squared plus 1 dx. One very important condition here that I need to mention is this function must be continuous on AB. If this function is not continuous, fundamental theorem of calculus is not applicable. We cannot use this. So the function must be continuous on A, comma, B. I'll write it again and again. So when I'm given a definite integral to calculate, first of all, I look at the function and say, is it continuous on -3, 4? Of course. It's polynomial. It's continuous everywhere. And then I proceed with the rule or the theorem. So first I have to identify what function prime is 4x squared. In other words, what function prime is x squared, to be exact. What do I get?
X cubed over 3.
Excellent. Plus, what function prime is 1?
1x.
Very good. Awesome. We have to put in parentheses whatever we obtained. So this is the antiderivative. We have to copy a vertical bar. I have to copy the -3, and I have to copy the 4. How do I continue? I plug in 4 everywhere. 4 times 4 to the 3rd over 3 plus 4 minus, please put parentheses, because we have to subtract all terms that follow. -3 to the 3rd is -27. So 4/3 times -27 and -3. So let's see what we get. So this is basically 4 to the 4th. 64 times 4 over 3. This is 64 times 4, yes, plus 4. Here I will simplify and I get -9, -36 plus 36, and then plus 3. So I have 256 over 3. This is plus 43. And then what do I get? 256. And I multiply this by 3. So 129 over 3. So the answer is, so 5, 8, and 3 divided by 3. So the definite integral, we found the antiderivative. We put in -3 to 4. We have to start by plugging in 4. We have to subtract when we plug in -3. We have to be very careful with these calculations. Very easy to make a mistake. Can I check? No. Can I check with the calculator? Yes. I have no way, unless I redo the calculations, I have no way of checking that whether this is correct. I can't. Here, can I? Yes. I differentiate this and I have to get this. If I don't, this is wrong. But here I cannot. However, I do have a calculator to check this number. So here's how we do it.